Hello everyone. Today I'm going to be talking about the flight director and the autopilot system used in the Primus 1000 avionics package. This flight director and autopilot is used in the later 500 series citations as well as the XL and XLS. So the Ultra and the Encore in the 500 series use this, and the XL and the XLS in the 560 XL line. The panel that I'm working with today is in a Citation XLS. Notice the color primary flight display. The flight director and autopilot system is identical throughout this fleet. So even though the individual specific display that you're seeing today looks a little bit different in the XLS compared to the XL or the Ultra or the Encore, the modes are all the same, the buttons are all the same, the underlying workings of the system are all identical across all these aircraft. So try not to get too caught up in the exact way that the display is on the primary flight display, and just to pay attention to the underlying explanations that I'm giving here. Okay, let's start with how you turn the system on. The flight director mode selector panel is this bar right up here at the top of the primary flight display. And these buttons allow the pilot to select both lateral and vertical guidance that they want from the flight director. And there's some variations across the different aircraft you might encounter with how these flight director buttons are placed and what they mean. In the XLS, there's a panel above the primary flight display on each side of the cockpit. So we have one on the pilot side here, as well as one over here on the co-pilot side. In other aircraft that you might fly, there might only be one of these located in the center of the panel. And in the XLS, these are tied together, so anything that I select over here, if I select heading mode over here, it will automatically engage heading and the mode over on the co-pilot side. That is a feature that is specific to the XLS. There might be other times where these mode selector panels are unlinked, so the pilot on the left side might select a mode and it does not actually carry over to the other side of the cockpit. So that's something to be aware of. Of course, if you only have one of these panels in the center of the instrument panel, then that would control both flight directors on both the co-pilot and the pilot side. When it comes to engaging the autopilot, the autopilot controls are all down in the center pedestal of the aircraft right here. And these are used to engage the autopilot and the yaw damper, as well as bank limit and pitch control on the flight director, which I'll explain here in a moment. It's good operating practice to always select the flight director modes and be able to see what the flight director is commanding before engaging the autopilot. But let's just suppose, for the sake of understanding the system better, let's just suppose that you just turn the autopilot on and don't have any modes prior to that selected on the flight director mode selector panel. What I'm going to do is come down here to the autopilot controller and just turn it on. There's tube lights that light up that say engage, and the autopilot engages and the yaw damper also engages. So there's no way to engage the autopilot without engaging the yaw damper. However, we can fly with the autopilot turned off and the yaw damper engaged, of course. When we first turn that system on, notice that's the only button I pressed. We come up to the flight director scoreboard, so to speak, and notice it says roll and pitch. This is the kind of the underlying modes that are always available for both lateral and vertical guidance. The important thing to understand about roll mode is that it's kind of a wings leveler mode and kind of a heading hold mode. So if the system is switched into roll mode, while in level flight or close to level flight, if it's within 6 degrees bank of level, the system will level the wings and try to track whatever heading the aircraft was flying at the moment the system was engaged. If the aircraft is in a bank, like say you're in a 30-degree bank turn and roll mode becomes engaged, again, it will try to level the wings. And as the wings are coming level, whatever heading the aircraft is flying as the wings come through 6 degrees of bank angle, it will lock onto that heading and try to fly that heading from that point on. Now, pitch mode is just what it sounds like. It's a simple pitch mode that will lock to whatever pitch attitude the aircraft had at the moment the system was engaged, or the moment that that system was turned on. Okay, the next important lesson that I want you to think about is something known as kind of like a scoreboard here. Some pilots will call this area of the primary flight display the scoreboard. The reason that we pay so much attention to this area is because this is your ultimate area for determining what the flight director and or the autopilot are doing. So even though each of these lights on, even though each of these buttons on the flight director mode selector panel have lights associated with them. See, if I go into heading mode, this light turns on. Even though that has a light associated with it on the button itself, we can't use that light to determine exactly what the autopilot is doing or the flight director is doing. We need to see the actual indications on the primary flight display. And the autopilot down here, the disengage button also has, or the the status of the system is displayed in this light here. But really, we can't totally trust this light, because if it burns out, it might indicate or seem to indicate that the autopilot's not engaged, when in reality, we see up here it says autopilot engaged. So now let me disengage the autopilot. We get a tone, and the symbols flash up here that says autopilot off. That's the true indication that we're no longer using the autopilot. Okay, so now I want to show the different means that can be used to disengage the autopilot. There's several different options for disengaging the autopilot. First of all, we can use the autopilot disconnect button, this red button up here on the top of the yoke. We can also use just moving the pitch trim here will cause the autopilot to disengage. Of course, pressing the autopilot engage button down here on the control on the center pedestal will also disengage the autopilot. We can also press the takeoff go around button right here in the thumb portion of the throttles. I'll talk about that in a moment. And last but not least, if the stick shaker engages, if we were approaching a stall and the stick shaker engages, that would also cause the autopilot to automatically disconnect. So I'll do that here just to give you a quick illustration of how that works. There's the stick shaker, the autopilot disengages. I'm using the rotary test to turn the stick shaker on. I'll turn that back off and reset the system using the red disconnect button there. Okay, something to note with these various methods also. If you use the red disconnect button here, this will clear both the autopilot and the yaw damp. If you only move the pitch trim, it will disengage the autopilot, but it will leave the yaw damp engaged. If you use this button down here on the control panel, you can turn off the autopilot individually, also leaving the yaw damp engaged. And if you use the takeoff go-around button on the throttles, that will also leave the yaw damp engaged, even though the autopilot is disengaged. So really, everything other that you'll see in normal flying will leave the yaw damp engaged, with the exception of the red disconnect button. That will clear both. Now, the last item I'll point out before getting deeper into the modes that are available is this arrow here that indicates which pilot is controlling the autopilot. So the default is for the system to power on and use the left side, the number 1 primary flight display, which is what is typically used by the captain in the left seat. However, that can be changed to be operated by the co-pilot or whoever's sitting in the right seat. The way to change that is by using this selector right here that says Flight Director Autopilot PFD1. If we press this button, we see PFD number 2 illuminate. And now when we come up and look at the scoreboard, notice we have an arrow that points to the right side. So in the XLS, this really is not a real significant change because, as I pointed out earlier, the flight director mode selector panels are tied together. So there's never going to be a disagreement there. In the XLS, the main thing this changes is the fact that the barometric pressure, the altimeter setting on the right side is used for the altitude hold mode. But if you're flying an aircraft like an XL, or I'm sorry, yeah, it could be an XL or an Ultra or an Encore that has 2 mode selector panels that are not tied together the way the XLS is, you could have completely different modes selected on the right and the left side. And of course, that would make a significant difference in how the flight director is issuing its commands. A couple more controls to note here on the center pedestal controller is the turn knob. The turn knob really isn't used in day-to-day flying. It allows you to command turns when in roll mode. So if you just twist it out of the center detent like that, you could command a turn to the right. And then there's a little detent that it locks into in the middle. Something that will trip pilots up with this literally is that if the turn knob is out of the center detent, the autopilot will not be engaged, or will not allow it to be engaged. So as you're climbing in and out, sometimes this knob gets kicked, and then when you're doing an autopilot check at the start of the flight, it won't engage, and you wonder what's going on, and all you have to do is center up the turn knob. This will also be enunciated on the scoreboard, so to speak. When I look up here at the scoreboard, I'll turn the turn knob out of the center detent. You see it flashing there in the middle. And then when I put it back in the center detent, the flashing stops. When it comes to this bank limit button, button, if it's illuminated, it says the word low, L-O-W. And what bank limit low means is it will limit the bank angle of the aircraft to 15 degrees of bank. This is used in heading mode if for some reason you want to do a slower rate of turn or just be a little bit gentler. You can press this button and it will engage the low limit at any altitude. And then at higher altitudes in heading mode, it will also engage automatically. So if we are above 32,000 feet in heading mode, that's the magic number to know that if you initiate a turn in heading mode, it will automatically be in bank limit low. That's sort of a safeguard for if you're up at higher altitudes, 40-some thousand feet at higher weights and on a hot day, and you have a high angle of attack, and obviously you don't want to get close to a stall at those altitudes. It's a little bit of a protection there to keep the aircraft from banking too aggressively at high altitudes. And then as you descend down through 32,000 feet during descent, it will automatically disengage the bank limit low as you descend to the lower altitudes, unless you turn it on manually. Okay, real quickly moving through the modes that are available here now. We've got heading, nav, approach, back course, VNAV, altitude, vertical speed, and flight level change, or filch. Notice that the left side has all of your lateral modes, and the right side has all of your vertical modes. Now, if we were to engage a given mode, say a lateral mode, it would, of course, go into that mode laterally, and then pitch mode would be the default for vertical. And vice versa, if we were to engage a vertical mode, then the roll mode would be the default lateral mode that the system would engage to. So let's say I select heading. It turns on heading and pitch and gives us command bars that will track the heading bug and maintain the same pitch attitude as the moment that we engage the system. Nav mode is used to track whatever is displayed on the CDI needle down here. So that could be the lateral guidance of an ILS, it could be a VOR, or whatever is programmed into the FMS through a GPS signal. Whatever you have on the CDI needle is tracked using nav mode. Approach mode is used exclusively for ILS approaches. When approach mode is engaged, it will lock on to the lateral guidance of a localizer as well as the vertical guidance of a glide slope, and that's only used during ILS approaches. BC for back course. This mode here is used when flying a localizer back course instrument approach, and this basically reverses the commands the autopilot is giving for lateral guidance. So if you're needing to fly a back course approach, you would set the CDI needle down here to the same course as the front course. So, for example, if you're going to fly a localizer back course runway 36 approach, you would twist the CDI needle to have the head of the needle at 180. You know, it would be based on a runway 18 localizer, and then you would select back course up here on the flight director mode selector panel. The VNav function is used for vertical navigation, and that needs to be programmed in the FMS for things like coming down stars and crossing various waypoints at specific altitudes. I need to show an example of that in flight to really understand it here. The alt function is for holding a specific altitude. The key to remember with the altitude function is that if it's not currently engaged and you turn it on, when you press the alt button, it will lock on to the present altitude that you're flying at and try to maintain that altitude. So some pilots get confused when they're transitioning into this aircraft and they think that they need to somehow arm the altitude, like if they're climbing towards a certain altitude, they need to press that button in order to stop at the programmed altitude, and that's not the case. That all happens automatically. You really only need to press the button Alt if you want to stop at the altitude you're currently at. Like if for some reason ATC says to stop your descent immediately, then you would press that button in order to lock onto your present altitude. VS for vertical speed is just what it sounds like. It allows you to select a specific vertical speed, and when you engage vertical speed mode, you use the wheel down here on the center pedestal to roll the pitch of the aircraft forward to descend or back to climb, and by rolling that wheel, then you can set the vertical speed to whatever you desire. FLC, or flight level change. This button is used to maintain a given airspeed. So when you turn on flight level change, it will lock to the speed the aircraft is presently at, and then from that point on, it will try to maintain that speed. So if you lock to a given speed and then you decrease power, it will begin descending, and if you increase power, it will start climbing. Of course, if you roll the control wheel on the center pedestal forward, it will increase the speed, and if you roll it aft, it will decrease the targeted speed that it's trying to hold. something else to keep in mind with flight level change is that at lower altitudes it will target speeds in knots, and then at higher altitudes it will target the speed in Mach number, a fraction of the speed of sound. The last item I want to talk about here until giving an in-flight example is the takeoff go-around button on the throttles. When this is pressed, it commands the flight director to go into roll mode, which if you remember is basically a wings leveler that will track the present heading, and 10 degrees pitch up. So that pitch attitude will be commanded on the flight director, and the autopilot will disengage, but the yaw damp will stay engaged. So I'll press that takeoff go around button right now when we're sitting on the ground, just to give you an example of what happens. There you go. See, it says roll mode, go around, 10 degrees pitch up. Alright, so go into pitch mode. 360.
Good evening, Chef. Chicago Center, Citation 556, Mike.
360 set and armed.
290 for 320.
Citation 556, Mike Whiskey, Chicago Center, climb, maintain file 360.
360, 6 Mike Whiskey.
What's your planned Mach number at altitude?
.63 for 6 Mike Whiskey.
You do 6.7 at least?
I doubt it, sir, unless we're lower.
Or 6 Mike Whiskey, can you do Mach 6.7?
Negative.
1,000 to climb. Still armed. 35, coming 36.
Cross on 135.9 or 7.
35, 9 or 7.
Somebody want to lower?
Chicago Center, 357, climbing 360. Centermost with a head climb maintained, flight level 400. Climbing 40. Chicago load up 787, checking in 370.
400 set and armed.
Delta 787, Chicago Centermost with a head.
Alright, here's an explanation of how we set up the vertical guidance to use the VNAV function of the autopilot. We start by pressing the VNAV key on the FMS, and it brings up this menu here. And I want to cross Bixby, the intersection Bixby, at 3,100. This is the initial approach fix for an approach that we might be flying, and 3,100 is the minimum altitude to cross that at. So I highlight where it says 4808, I press that soft key, and I just type in 3,100, press enter to that. And right now it says that if we are flying this ground speed in, we would need to come down at 1,200 feet per minute to cross at that altitude. I'll start by pressing enter to the 2,200 for the target vertical speed. And it gives me an angle of about 4.31 degrees. That's too steep. Even at powered idle, that's hard to come down that steep. So what I'm going to do is I'm going to change that to about 1,700 here. We'll see if that gives us a more comfortable angle. Yeah, and I usually target anywhere between about 3 and 3.5 degrees. That's the angle through space coming down. And it tells us that our top of descent is 5 minutes from now.
We got discretion to 16.
Roger. All right, so we have 16,000 set in the alerter. Notice that it has not armed yet because we have not actually started trending in that direction. We have to start trending in that direction before the altitude select arm window illuminates to indicate that we'll level off at 16,000. When we get within about 10 miles of the top of descent, the FMS gives us a message that says top of descent alert. And what that means is that at this point we can arm the VNAV function. So notice that when I select VNAV, it illuminates as a standing by mode off to the side. And we'll look at this FMS guidance here vertically. It looks like a ILS glide path indication, and that will basically come into view, and the VNAV mode will lock onto that and start heading down to cross that restriction that I put in to cross Bigby at 3,100. Okay, the vertical path is almost ready to intercept. Now notice that VNAV mode is active, and we've started down, and altitude select arm has lit up to indicate that we will level off at 16,000 when we get there. Of course, as this is capturing, since we don't have auto throttles, we have to bring the throttles to a reduced power setting to maintain the same speed. A couple of the last modes that I want to point out with the flight director and autopilot here are how things will revert back into pitch and roll mode if mode is disengaged. So, for example, here I'm out of VNAV mode now because we're on a vector, and I would normally descend in vertical speed mode, but if for some reason I disengage vertical speed mode, it would revert to pitch mode and would just hold the present pitch attitude. And then, of course, if I turn vertical speed back on, it re-engages at the current vertical speed. Same thing would happen with heading mode, where if I disengage heading mode, it would go into roll mode and just keep the wings level and keep tracking the present heading. And then, of course, if I turn heading mode back on, it tracks the heading bug.